Have you ever wished your phone could last for days on a single charge? Or that an electric car could drive hundreds of extra miles before needing to plug in? This dream might become a reality very soon, thanks to an amazing new technology called solid-state batteries. These aren't just slightly better batteries, they are a complete rethinking of how we store energy. They promise to make our gadgets last longer, our electric cars drive farther, and our world a little bit greener. This incredible invention could change everything we think we know about power, starting with the very devices we use every single day in our homes, schools, and workplaces. So, what exactly is a solid-state battery? Let's break it down with a simple idea. Think of a regular battery, like the one in your phone, as a sandwich with a liquid filling. This liquid, called an electrolyte, helps electricity move from one side of the battery to the other. It works, but this liquid can be a bit unstable and can even catch fire if something goes wrong. A solid-state battery replaces that gooey liquid filling with something solid. Imagine using a thin slice of a special ceramic or glass instead. This solid material does the same job of moving energy, but in a much safer and more efficient way. This simple switch from a liquid to a solid has huge consequences. The solid electrolyte is much more stable and can't leak or spill like a liquid can. This immediately makes the battery safer. Because the internal parts are made of solid, non-flammable materials, the risk of fires that you sometimes hear about with current batteries is greatly reduced. This is a massive step forward for safety, especially for things like electric cars or even medical devices that are implanted inside our bodies. It's a foundational change that unlocks a whole new level of reliability and peace of mind for technology users. The science behind this is truly fascinating. In any battery, tiny charged particles called ions have to travel through the electrolyte to create an electric current. In today's lithium-ion batteries, these ions swim through the liquid. In a solid-state battery, they must hop through a solid crystal structure. Scientists have been working for years to find the perfect solid materials that allow these ions to move just as quickly as they do in a liquid. It's like building a superhighway for ions, but one that is completely solid, stable, and incredibly compact, paving the way for a new generation of powerful and safe electronics. When we compare solid-state batteries to the lithium-ion batteries we use now, the benefits become very clear. The most important advantage is safety. The liquid electrolyte in lithium-ion batteries is flammable. If the battery gets damaged or overheats, it can lead to a dangerous fire. Solid-state batteries with their solid, non-flammable electrolyte are much less likely to have this problem. This makes them a much safer choice for electric vehicles, where a battery pack is very large, and for consumer electronics that we carry with us everywhere. This added safety could give people more confidence in adopting new green technologies. Another major benefit is efficiency and energy density. Energy density means how much power you can pack into a certain amount of space. Solid-state batteries can store much more energy in the same size or even a smaller size compared to lithium-ion batteries. For you, this means a smartphone that could last for 2 or 3 days instead of just one. For an electric car, it could mean driving 500 miles or more on a single charge, which is similar to a gasoline-powered car. This would eliminate range anxiety, the fear that an electric car will run out of power before reaching a charging station. Solid-state batteries also have the potential to last much longer. Over time, regular lithium-ion batteries start to lose their ability to hold a full charge. This is why your phone battery seems to die faster after you have owned it for a couple of years. Solid-state batteries are expected to have a much longer lifespan, meaning they could be recharged thousands more times without losing much of their capacity. This is not only better for our wallets, because we wouldn't need to replace devices as often, but it is also much better for the environment. Fewer discarded batteries means less electronic waste in our landfills. Finally, let's talk about charging speed. We all know how long it can take to charge our devices. Imagine plugging in your electric car and having it reach 80% charge in just 10 to 15 minutes, about the same time it takes to fill a car with gas. Researchers believe solid-state technology can make this possible. The stable solid structure can handle faster flows of electricity without getting damaged or overheating. This would make owning an electric car just as convenient as owning a traditional one, completely changing the game for transportation and making our cities cleaner and quieter for everyone. The idea of a solid-state battery isn't brand new. Scientists have been experimenting with it in laboratories for decades. For a long time, it was just a fascinating concept, a theoretical dream. Researchers would create tiny, coin-sized prototypes in carefully controlled environments to prove that the science worked. They tested different solid materials, trying to find one that allowed electricity to flow quickly and reliably. These early experiments were a critical first step, showing the world that a battery without any liquid was not just possible, but held incredible potential. They were the building blocks for the revolution we are starting to see today. In recent years, we have seen exciting progress as this technology moves from the lab into early real-world tests. Several major companies in the automotive and technology industries have invested billions of dollars to make solid-state batteries a reality. They have built larger prototypes and are now testing them in actual devices and vehicles. Some companies have already demonstrated solid-state batteries powering electric scooters or drones, and a few have even showcased them in concept cars. These tests are designed to see how the batteries perform under real-world conditions, like changing temperatures, vibrations from driving, and repeated fast charging cycles. One of the biggest milestones has been the development of manufacturing techniques. Making a single solid-state battery in a lab is one thing, but producing millions of them affordably is a completely different challenge. Companies are now building pilot production lines to figure out how to make these batteries at a large scale. This involves creating new machinery and perfecting the process of layering the delicate, ultra-thin solid materials with precision. Every successful production run brings us one step closer to seeing these batteries in the products we buy, marking a significant leap from pure research to commercial viability. We are now on the verge of the first commercial applications. Some experts predict that the first products with solid-state batteries, perhaps high-end electronics or specialized medical devices, could be available within the next couple of years. Major car manufacturers have also announced plans to introduce electric vehicles powered by solid-state batteries by the middle of this decade. While it will take time for them to become common, these first steps are incredibly important. They will prove that the technology works in the hands of consumers and will pave the way for wider adoption across all industries. Despite all the exciting progress, there are still significant challenges to overcome before solid-state batteries are everywhere. The biggest hurdle right now is cost. The special materials used for the solid electrolyte and the complex manufacturing processes currently make solid-state batteries much more expensive to produce than traditional lithium-ion batteries. For this technology to be successful, companies must find ways to lower these costs so that they can be used in everyday products like phones and affordable cars. Scientists and engineers are working hard to discover cheaper materials and simpler production methods to solve this problem. Another technical obstacle is durability. While solid-state batteries are expected to last longer in theory, the solid materials can be brittle. Over many charging and discharging cycles, the materials inside the battery expand and contract slightly. In a solid structure, this can cause tiny cracks to form, which can stop the flow of electricity and cause the battery to fail. Engineers are developing more flexible solid materials and clever battery designs to prevent this from happening. Ensuring these batteries can withstand thousands of cycles without breaking down is key to making them a reliable power source for long-term use. Furthermore, scaling up production from a small pilot line to a massive factory that can produce millions of batteries per year is a huge industrial challenge. It requires building entirely new supply chains for the raw materials and inventing new quality control techniques to ensure every single battery is perfect. Any small defect in the solid layers could ruin the entire battery. This massive undertaking requires enormous investment and coordination between scientists, engineers, and manufacturers. It is a slow and careful process, but it is essential for bringing this revolutionary technology to the global market. If we can overcome these challenges, the future powered by solid-state batteries is incredibly bright. Imagine a world where electric airplanes can safely fly long distances, where entire communities can store solar and wind energy in large, safe battery banks, and where our personal electronics work for days on end. This technology has the power to accelerate our transition to a cleaner, more sustainable world. So the next time you plug in your phone, think about the amazing science happening right now to create the next generation of power. What other parts of our lives do you think could be transformed by a better battery?